of the only sources of snapshot hyperspectral imaging beside of IMAC, which came, in my opinion, 1 or 2 months later. I don't know. Who knows? So we do spectral imaging since then, and a lot of our customers use our devices specifically for agriculture research and agriculture developments. So the question is, why is hyperspectral imaging important for agriculture research? There are multiple reasons we see which get more important over time. So due to climate change, we see a lot of people's interest in changes of biological systems. So real-time data and easy accessible data is of high importance right now. We also try to bridge a gap between satellite data and ground truth data with a UAV mounted hyperspectral camera. And we see that there's a constant need of real-time data. Example given with KWS, we also had a short study in 2014 with your colleague. And unfortunately, at that time, our system was very limited in spectral resolution. So we only had 50 by 50 hyperspectral pixels, which was not enough at that time. Otherwise, we might have had a cooperation with KWS as well, which is a proto customer of ours. So what we do is full frame hyperspectral imaging. So we always look for solutions to get a complete spectral cube with one sensor readout. That is a bit different to the other gold standard of spectral imaging, which is push broom, which is also regularly flown by our colleagues from Headwall or similar. However, I would say it's much more complicated to make a spectral map out of single lines which they measure. What we usually measure is a complete image, and we measure multiple images and they create a map. So I think I was not sure if it was clear what hyperspectral imaging or spectroscopy in itself is and what the difference to multispectral is. I guess in the talks we had today, it was quite clear. So for us, the difference is usually twofold. The first difference is multispectral. It's usually you have single wavelengths and not a spectrum. Secondly, with hyperspectral, you sometimes have better classification results for chemical sensing. If you have just one issue or one topic you want to have your data for, then multispectral is totally fine. And we also sell multispectral cameras with customer-defined channels. Sorry for the sound. I hope the video is somehow transmitted. So we have a full integration of our solution in a DJI 300 drone, which is a very interesting platform for a turnkey-ready solution. The DJI system already brings us very far with a very good integration of a mapping solution, of the autopilot, of a triggering and generating of a map. So this system enables you with 1 or 2 days of training to make your own mapping. And the camera provides 350 to 1000 nanometer wavelength range and captures hundreds and thousands of images from the top. The flight, so this is the system. It's based on a DJI Skyport, where the camera is fully integrated. So the only thing you have to do is plug it in and install the current software of ours, and then generate your flight planning. This is how an image of our system looks like. We have system which is twofold. We have a high resolution pan sensor, which gives you up to 1800 by 1800 pixels. This is used for stitching, and it's used for the high spatial resolution image or map you want to generate. Additionally, we have this hyperspectral snapshot camera, which has 400 by 400 pixels. Both are captured at the same time. And in the end, you can have a data product, which is 164 bands with 1800 by 1800 pixels. And this is just one image. So what we do when we fly is we capture one image a second or one or two images a second, and flying 10 minutes, and then you can imagine you have thousands of images with one map. The autopilot of the DJI flight system is programmed before the flight, where it should fly exactly, where it should capture the images. And after the flight, you will have, this is a very short map, by the way, you will have a multitude of images. Each of this rectangle represents one hyperspectral cube, and the direction of the UAV from which it was taken. And this is then fed into Argisoft Metashape, and a complete map, a complete hyperspectral map is generated. These data sets can be quite huge, so multiple gigabyte and such. The calculation of a data set like that can take a day. After the calculation, you have, in principle, a completely open data set which you can work with. It features a digital surface map, a 3D map of the surface evaluation, which already can give you some information, example, given the height of crops or biomass, applications I've seen people work on. But also you have multiple image formats and spectral calculations on the crops you are measuring. I have to admit that we are not the best experts in the applications itself, because what we concentrate on is have the easiest to work with flying hyperspectral mapper. And we have a big community of customers who are working in the agriculture field. So this is a survey we did a while ago, where we just went through the publications which were done with our systems. So we found 180 publications on a specific system, and we see that over 50% of our literature is in agriculture and food. This survey can be found on our website, by the way. So if you're interested in specific studies regarding applications in agriculture, that might be a good starting point to have a look. It's very extensive. But beside food and environment, we also have a lot of water spectroscopy, which tends to be similar because it's very often due to climate change. So we have a lot of customers interested in water quality, biodiversity, and the change of biodiversity during heating up times. But also if you are in forestry, which is very often CO2 related, so carbon, measuring the carbon footprint of forests is a big topic from our community right away. So overall, I just took, a very small chunk out of it. So you see, we see a lot of publications working on detection of plant health issues in multiple plants, in potatoes, in tea, in winter wheat, and so on and so on. So the amount of work which is put in by the community right now is tremendous, and we see still a rising amount of scientific research going on in this field. And we hope we can do our part to help our scientific community to be successful here. yeah, it's quite some simplifications. So overall, I just wanted to use the chance here to say thank you to our customers, to be honest, because without them, we wouldn't be here. And we know that we can only do so much. And so I also want to say we are very happy about feedback. If there's any feedback here, we are super happy to know it. And how far our customers brought us is shown in this image because I just pulled it up. This was the very first camera we ever produced. And this was for an agriculture application as well. So this is a gentleman from the Uni Hohenheim here in Germany, and they did mango analysis, mango health analysis. And this was in 2012, so nearly 13 years ago. And so the topic didn't change, just the technology changed a bit, and we try to keep up with the best technology we can provide. Yeah, thank you very much.
Thank you, Rooney. Thank you very much.